Assalamu alaikum. How are you, students? I hope all of you are well. Today we are going to start chapter number 2, Real and Complex Numbers. But before we proceed further, let me ask you something. I'm going to write down a set of numbers over here. This is called set of natural numbers. Now if I add a special number 0, as all of you know, 2 minus 2 will give you 0. Similarly, minus 5 plus 5 will give you 0. So if we add this special number 0 to the set of natural numbers, the set would become set of whole numbers. Okay students, now if we add a number like 1 minus 2 will give you what? Minus 1. Similarly, 4 minus 6 gives you what? Minus 2. So these are which integers? These are negative integers. So if we add negative integers to the set of whole numbers, this set would become what? 0 plus minus 1 plus minus 2 plus minus 3, so on. This is called what? Set of integers. Or we can write a set of integers in this form as well, like minus 3, minus 2, minus 1, 0, 1, 2, so on. Like positive integers on the right side of 0 and negative integers on the left side. So this set is called set of integers. Okay students, there are some other numbers which are called fractions. That is, for example, 1 by 2, minus 3 by 5, 1 by 6, and so on. These all are fractions. There are some other type of numbers which are called decimal fractions. Fine? Decimal fractions. So let us see how many type of decimal fractions are. If we convert these fractions into the decimal form, how would we convert into the decimal form? Definitely by division. So let us change 1 by 2 into the decimal form. How will we change decimal into the decimal form? We will divide 1 by 2. So as all of you know how to divide, we will introduce a decimal point over here and then a 0. Now we will multiply 2 by 5 and our answer would be 10. So it means 1 by 2 when converted into the decimal form will give you 0.5. So there is just one digit after the decimal point. Now if we convert some other number, for example 22 by 7 into the decimal form. Okay, now if we divide 22 by 7, so 7 into 3, 21. Our remainder would be what? Yes, 1. Now can we divide 1 by 7? Absolutely not. So we will introduce a decimal point over here and then a 0. Now 7 into 1, 7. What is our remainder? 3. Now we will again introduce a 0 and now we will divide 7 into 4, 28. As all of you can see, the division is not going to be n. We are not having a remainder as 0. It means division will go on. So 22 by 7 will give you what? 3.14. And dot dot dot. What does mean by this dot dot dot? The division is going to be continued. Okay, let us take another fraction, that is 1 by 3. Now let us divide it. Can we divide 1 by 3? Absolutely not, because 1 is less than 3. So we will introduce a decimal point over here and then a 0. So 3 into 3 will give you 9. Now what is our remainder? That is again 1. We will again introduce a 0 over here and our answer would be 3 into 3, 9. As all of you can see that every time we will have 1 as a remainder and we will introduce another 0 and our division will go on. Isn't it? Our division will go on because we are not going to have remainder as 0. It means when we divide 1 by 3, our answer is 0.333 and so on. Now can you tell me the difference between the answer of 1 by 2, that is 0.5, and the answer of 22 by 7, that is 3.14, and the answer of 1 by 3, that is 0.333, so on. Yes, the first one is 1 by 2 is equals to 0.5. When we convert it into the decimal form, our answer is a terminating decimal fraction. Now what does it mean by terminating? Yes, terminating means in which the number of digits after the decimal point will stop, will terminate. So this is a terminating decimal fraction. And what about 22 by 7? Our answer over here is 3.14, and as division was not stopped over here, so it is 3.14 ... It means it is a non-terminating decimal fraction. So what does it mean by non-terminating decimal fraction? In which the number of digits after the decimal point will not stop. Now what about this? What is the difference between 22 by 7 and 1 by 3? Can somebody tell me what is the difference over here? Yes, you can see the difference. The similarity in this is the number of digits after the decimal point does not stop anywhere. And what about the difference? The number of digits after the decimal point are different. And here the number of digits after the decimal point are repeating. So we can say this is a decimal fraction in which we can call it as recurring decimal fraction. Recurring decimal fraction. And what we will call this? This is a non-recurring decimal fraction. Non-recurring decimal fraction. So now we can divide or we can classify the decimal fractions into two main types. Decimal fractions into two main types. So first type is called what? Terminating decimal fraction. And what are terminating decimal fractions? In which the number of digits after the decimal point will stop or will terminate. And what about the second one? That is non-terminating decimal fractions. These two are non-terminating decimal fractions. But what is the difference between them? Non-terminating decimal fractions. So what is the difference among them? The number of digits after the decimal point will not stop. And here the number of digits after the decimal point will stop. Now non-terminating fractions, decimal fractions are further divided into two main types. One of them is called what? Recurring decimal fractions. What are recurring decimal fractions? Recurring decimal fractions are the fractions in which the number of digits or a digit or a group of digits after the decimal point will repeat indefinitely. Fine? Recurring decimal fractions. And non-recurring are definitely which one? Non-recurring decimal fractions are the fractions in which the number of digits after the decimal point will not repeat, fine, they would be different. So non-recurring decimal fractions are these fractions. So students, let us define rational numbers now. What are rational numbers? Rational numbers are the numbers which can be written in P over Q form. We denote the set of rational numbers with Q, and the set of rational numbers are the numbers which can be written in P over Q form, that is, in the fraction form. Here P and Q belongs to, this sign is for the belongs to. So P and Q belongs to the set of integers, and Q is not equals to 0. Fine? So we can have 1 by 2 as a set of as a rational number, similarly minus 3 by 5, and so on. The numbers which can be written in the fraction form. But there is another question which arises over here. If the numbers which are in the fraction form are the rational numbers, so what about 22 by 7? We call 22 by 7 as pi. This is a number which can be written in the fractional form. But is it a rational number? No, it is not a rational number. It is not a rational number. Why it is not a rational number? Because there is another definition for the rational numbers. The numbers which are terminating decimal fractions are called rational numbers. Terminating decimal fractions are called rational numbers, that is 0.5, 0.235, so on, whatever, in which the number of digits after the decimal point will stop or terminate somewhere. But if they are non-terminating, then what should we have? Non-terminating and recurring decimal fractions. Recurring decimal fractions. So the fractions, decimal fractions which are non-terminating and are recurring. For example, can somebody give me an example over here? Yes. The numbers which are non-terminating and recurring, that is, the number of digits after the decimal point will not stop, and recurring means the number of digits or a group of digits will repeat itself. For example, 0.333, so on. It is a non-terminating and it is recurring. Recurring means a digit or a group of digits will repeat indefinitely after the decimal point. Can somebody give me another example? You can find some other examples as well. For example, 0.232323, so on. Here, a group of 2 digits are repeating indefinitely after the decimal point. So the rational numbers are the numbers which can be written in P over Q form, and which are terminating decimal fractions, and which are non-terminating and recurring decimal fractions. Fine. So pi is equal to 22 by 7 is not a rational number, because it is what? Pi is equals to 22 by 7 is what? It is a non-terminating but non-recurring as well. That's why it is not a rational number. So there is another set of numbers which is called irrational numbers, which are called irrational numbers. So irrational numbers are defined as the numbers which cannot be written in P over Q form. The numbers which cannot be written in P over Q form, and where P and Q belongs to the integers and Q is not equals to 0. Fine. So now we can conclude that there is a set of natural numbers. We can say it is a proper subset of set of whole numbers. That set of whole numbers is a proper subset of set of what? Set of integers. Set of integers is a proper subset of set of rational numbers, and set of rational numbers is a proper set of real numbers. As a set of natural number, whole number has one extra element, that is 0. Set of integers has a lot of extra elements which are negative integers, when we add negative integers to the set of whole numbers. Similarly, rational numbers have fractional numbers or the decimal fractions as well. Then set of real numbers come. So here we can say, if we make a Venn diagram for this, if this is a set of real numbers, so we can say set of natural number is a proper subset of set of whole numbers. Then set of whole numbers is a proper subset of set of integers. And set of integers is a proper subset of set of rational numbers. But what about the irrational numbers? The numbers which are rational are not irrational. It means rational and irrational are totally different. So what can we say? Rational numbers and the intersection of the irrational numbers is what? Set of empty set or null set or phi. Similarly, if we can say the union of the rational and the irrational, what it would be? When we combine the rational and irrational, it would become what? Set of real numbers. Fine? So students, today we studied about the rational and irrational numbers. Okay students, let us write down few of the examples of the irrational numbers. Irrational numbers. So the numbers which cannot be written in P over Q form are called irrational. We denote it by Q dash, that is x, such that x is not equals to P over Q, and PQ belongs to what? Integers, while this sign is for and Q is not equals to 0. So what about the examples of the irrational numbers? The square root of the prime numbers, that is square root of 2. It cannot be written in P over Q form. Similarly, square root of 3. Similarly, square root of 5. And so on. That is, square root of the prime numbers are irrational. Why they are irrational? As we studied earlier, that non-terminating and non-recurring fractions, decimal fractions, are what? They are irrational numbers. Fine, non-terminating and non-recurring. You can check your answers as well. When you find out the answer of square root 2, it will be non-terminating and non-recurring. Square root 3, similarly square root 5, and so on. So we can conclude that square roots of prime numbers are what? Irrational. Square root of prime numbers are irrational. Similarly, square root of the non-square positive integers, square root of non-square positive integers are also what? Positive integers are also the examples of the irrational number. For example, square root of the numbers which are prime, square root of prime numbers are irrational, and the square root of the non-square. Non-square means, for example, you can take square root of 6. Fine, this is a non-square. That is, what about the non-square? Let me explain it. Square root of 4. This is what? This is the square root of a square of a number. Here we can cancel square with square root and our answer would be 2. Similarly, square root of 9. Okay, exercise 2.1, we are going to start exercise 2.1 now. What is the first question of exercise 2.1? You have to open your books with you as well. So first question is, identify which of the following are rational or irrational. So the first part of question number 1 is square root of 3. Yes, Square root of 3, is it a rational or irrational? As we have just studied that square root of the prime numbers are irrational. So it means this is an irrational number. And you can check your answer as well. When you will find out the square root of 3 from the calculator, your answer would be a non-terminating and a non-recurring decimal fraction. So this is an irrational number. So what about second part? That is 1 by 6. As it is written in P over Q form. But that does not ensure that it is a rational number. For this we have to check it that whether it is a terminating, non-terminating or a non-recurring, whatever this is. So we will divide 1 by 6. Can we divide it? No, 1 is less than 6. We will introduce a decimal point over here and then a 0. 6 into 1, 6. What would be our remainder? Our remainder is 4. Now we can introduce a 0 over here. So 6 into 6 will give you 36. Again, remainder would be 4. And it means our division will go on. Our division will go on. It will not stop. So answer of 1.1 by 6 is 0.1666, so on. That is, the digit 6 is repeating indefinitely. So we studied the fraction is what? Which type of fraction? It is a non-terminating, but it is a recurring decimal fraction. A digit or a group of digits when repeat indefinitely after the decimal point, that is called a recurring decimal fraction. So it is a non-terminating and recurring. And non-terminating and recurring decimal fractions are called what? They are called rational numbers. So 1 by 6 is a rational number. I hope students this is clear to you. Now what you have to do is, you have to do the remaining parts by yourself. Okay students, now we are going to solve question number 2 of exercise 2.1. Question number 2 is to convert some fractions into the decimal form. Convert into decimal form. So this is a very easy question. First part is 17 by 25. So our first part is 17 by 25. How would you convert it into the decimal form? Definitely by division. So all of you know the procedure of division as you have done it in the previous classes. So can we divide 17 by 25? Numerator would become the number which we will write down inside this, that is dividend, and the denominator would become divisor. So can we divide 17 by 25? Definitely not. We will introduce a decimal point and then a 0 over here. Now what about this? Can we divide 170 by 25? Yes, of course. 25 into 6 will give you 150. Fine. So what would be our remainder? Remainder would be 20. Now can we divide 20 by 25? Definitely not. We will introduce another 0 over here, and 25 into 8 will give you 200. Here our division will stop, or we are having a remainder as 0. It means 17 over 25 when converted into the decimal form will give you 0.68. So this is very simple question. So second part is 19 by 4. So here, what would be our dividend? That is 19, and our divisor would be 4. So 4 into 4 is 16, and here our remainder would be 3. Now can we divide 3 by 4? Definitely not. 3 is less than 4, so we will introduce a decimal point and then a 0. So 4 into 7 will give you 28. Fine. So here our remainder would be 2. Now we will introduce another 0, and 4 into 5 will give you 20. So 19 by 4 when converted into the decimal form will give you 4.75. Right? Now student, what you have to do, you will do the remaining parts by yourself on the similar pattern. And question number 3 is about the true and false. You will do this question by yourself as well, because this is regarding the rational and irrational numbers. Question number 3 is, which of the following statements are true and which are false? First one is 2 by 3 is an irrational number. 2 by 3 is an irrational number. So can somebody tell me, 2 by 3 is an irrational or a rational? It is in the P over Q form, fine, and you will convert it into the decimal form as well, and you will find out this is a rational number. This is not an irrational number, as it is already written in P over Q form. And for your further convenience, you can check your answer as well. You will divide 2 by 3 and you will find out that your answer would be terminating. So first statement is what? First statement is a false statement. So similarly, you will do the other parts by yourself, as the second part is pi is an irrational number. So this is a true statement, pi is an irrational number, as we studied. So here, first 3 questions of exercise 2.1 are completely done. You have to practice these questions, students. Okay, good luck.